new technology in the hands of independent actors can achieve far greater impact than top-down solutions. Today I want to talk about a challenge that we all face, the housing crisis. And more specifically, how with a slight change of how we think about technology, we can achieve a radical change of facing that crisis. So we all know the urban population is growing at rates that are as high as have ever been. And in one generation, in a nutshell, we have to double the amount of buildings that exist on the planet. And we have to do that by minimally increasing the land that cities take. So one of the most sustainable solutions is to keep a building extended instead of replacing it with a new one. But can we, with the tools we have today, with the business models we have today, can we actually achieve that? So let me bring you back to 130 years ago, to the story of the great manure crisis of 1894. At the late 19th century, cities were reliant on thousands of horses for transportation. And they produced so much manure that urban civilization seemed doomed. The Times predicted that by the mid-20th century, Londoners will be buried under 3 meters of horse excrement. So experts and conferences, they debated on that for years, and no solution seemed to be able to be found. And then, yet, by 1912, the problem went away because horses were replaced by motorized vehicles such as cars, trams, and buses. So for me, what that story kind of shows is that new technology in the hands of independent actors can achieve far greater impact than top-down solutions. So let's take a look at what is standing in the face of urban densification today. And I want to bring your attention to 4 things. First, we have limited structural capacity of the existing building and also limited access to the construction sites. Second, we have complicated and very unclear regulations, which makes it very difficult to imagine what exactly is possible on a given site. Third, we have to get the approval of multiple stakeholders that are not the investor. Tenants, residents, neighbors, municipality, the list goes on. And fourth, densification projects typically result in very small usable area added to a given plot, if you look at a single project. So this fragmentation results in what we would call low return on investment. How do we deal with the challenge of densification projects today? Very typically, most often they are initiated and led by architects who are able to see the potential in a given plot. They're super labor intensive, yet we get custom-tailored, mixed-use developments that, like jewels, make our cities more beautiful, but also like jewels, they are rare and expensive and practically unscalable. So can we keep this quality, but figure out a way to scale it up? Now, imagine that you can use generative design, product platforms, and mixed reality to overcome these obstacles. The 7DayHouse as a project combines these technologies to provide eco-friendly housing solutions for urban densification. The project is led by Professor Benjamin Dillenburger at ETH and Professor Daniel Hall, currently at TU Delft. And the goal is that we can generate a fully customized home in 1 day while maintaining supply chain continuity for fabrication and delivery within 7 days. And there are 5 key principles that guide us in the research that we're currently doing. First, we aim to build with wood. Engineered wood, like CLT or cross-laminated timber, offers multiple benefits that make it suitable for extensions. It's lightweight, so we can build more on top of existing buildings. It's highly compatible with CNC manufacturing, so we can manufacture parts that fit better to the constrained context. It is assembled fast and quietly, which means low disruption of the urban environment at the construction time. It's renewable and sequesters CO2, which allows us to save around 70% compared to concrete and steel of emissions. When exposed, it has psychological and physiological benefits for the inhabitants. And finally, but not the least, because we can build thinner walls, it allows us to get up to 10% more living space. The second principle that drives our research is that we think of interfaces and not in parts. So prefab, industrialized construction, we kind of tend to think about parts. But with new machinable materials like CLT, producing a unique part comes at the same speed and cost as producing multiple identical parts. So it's actually the interfaces or how parts come together that now defines the speed and the cost of a construction site. And if we can standardize these, we can actually reduce the cost and time and open up design freedom. And we're learning from computer games on how to develop generative design tools that use this idea of reusable interfaces between parts for design. A perfect illustration is this game toy Townscaper by Oskar Stahlberg. In it, it's just 6 core types of tiles that model how floor, wall, and roof come together that allows for this endless array of visually stunning cities. And in the 7DayHouse, we use the same approach to manage the complexity of assembly by mapping the interfaces between parts to tiles that represent design fragments. We can then computationally explore the potential combinations, and then we can learn out how to sort out the good ones from the misfits. Our third principle, I already hinted, we generate to order instead of engineer to order. Our algorithms can generate optimal floor plans for residential units that match site conditions, site constraints, user preferences, and regulations. But then we have another problem, right? If we can generate thousands of designs, how does a user, maybe even an architect will find it difficult, but what about a non-expert user? How do they pick one that fits, right? We're dealing with a problem that doesn't have an optimal solution, doesn't have an optimized state. It's actually an iterative kind of workflow that we follow here. So our fourth principle is that we let users playfully explore and iterate over the designs. We don't offer them solution, but with technologies such as mixed reality and most recently ChatGPT, we can imagine a whole new set of interactions between human and algorithms, so that people can interact in a very natural gestures, natural speech with a generative model. First, to explore what are its constraints of this project, what are the trade-offs, and then to drive the generated result to a state which fits their priorities, which can actually evolve as they work on the project. So the tools we developed allowed for this mixed reality interface to define preferred room locations, preferred room areas, preferred room connections, and then we can ask the generative algorithms, here's a very kind of rudimentary illustration to generate the layout that fits that configuration. We can visualize it on the table, so then maybe you can judge its qualities and start changing rooms again. And again, just as a kind of feature, sneak peek, we can move a human camera, human point of view, so we can immerse ourselves into the designed or generated design here. Visual representations like this, immersive and highly graphical, can also help us get stakeholders on board and secure project approvals much easier than now. And finally, Zurich again in different colors. The fifth principle that we follow is that one project can have multiple sites. And I don't mean that we take one project and build it on multiple locations the same. I mean multiple sites. When studies show that rooftop extensions are spread all around the city, but doing that, for example, in Germany, we can add 2.5 million homes in the cities. When we look at how Zurich plans to add 110,000 new homes in the next 15 years, according to the development plan that, after heated debates, was approved a couple of months ago, we actually see very little space for sustainable densification. Everything is so fragmented that from the current point of view, the only thing that makes sense is to replace all buildings with new ones. So here we need to think really outside of the box. With technology that is enabling the efficient creation and management of digital assets, we can also imagine the decentralized real estate asset. That is a collection of extensions that are dispersed in the city, but are designed at once, manufactured at once, assembled at once, and operated by a single entity, at a scale that makes this investment worthwhile. So that's my message, main message for you today, that when we're facing a crisis like the housing crisis, we need to change the way we think about scale. It's not necessarily the huge mass, the multi-thousand square meter development, but it could be a collection of uniquely shaped, dispersed rooftop or other extensions of buildings that share a flexible design and a flexible design construction system. Because just like the great manure crisis of 1894, the solution will not come from top-down mega plans, but it will emerge from getting technology into the hands of thousands and millions of people. And this is how we think of the next phase of architecture and construction, coupled with generative algorithms and product platforms. If we are successful, we can make thousands of homes possible and densify our cities in a sustainable way. Thank you, and looking forward to the discussion.